Hey Geometry! In this video we're going to be understanding chords and arcs. We have 3 rules about chords and arcs. Rule number 1, chords are congruent if and only if the measures of the arcs that they cut off are congruent. If and only if is a biconditional statement, meaning it's true both ways, forwards and backwards. So if I reread this as, if the chords are congruent, then the arcs that they cut off are congruent. And what that means by arcs that they cut off, from here to here, that's the arc that's been cut off. Same thing as this, cut off between the chord. So if the chords are congruent, then the arcs are congruent. Vice versa, if the arcs are congruent, then the chords are congruent. Rule number 2 is the most popular rule. You'll see rule number 2 and rule number 3 for the most part, just these two. Rule number 2, chords are congruent if and only if they are congruent from the center. Okay, another biconditional, so let's read that in the conditional statement. If a chord is congruent, or if 2 chords are congruent, then they are congruent from the center. And these markings on the chord are going to indicate that they are congruent. We don't have a way to just put one tick mark for this line as a whole because of it being cut here with that point from the center. So when you see 4 tick marks, 2 on each chord, we know that the chords as a whole are congruent to one another. So if the chords are congruent, then they're going to be the same distance from the center. Then these 2 pieces are going to be congruent as well. Backwards direction, if the chords are congruent from the center, if these 2 pieces are marked as congruent, then the chords are marked as congruent as well. Rule number 3 states that a diameter, this should say is, a diameter is perpendicular to a chord if and only if it bisects the chord. So another biconditional. So if a diameter is perpendicular to a chord, then it bisects the chord. If a diameter bisects the chord, then it is perpendicular. And that kind of gives us a hint as to why we have these perpendicular markings in rule number 2. That's coming from rule number 3. This piece right here, we can think of this as a diameter. This is from the center. If I were to extend this line all the way outward, that's a diameter. And that is showing it's perpendicular and being bisected. So if it's bisected, if perpendicular, then bisected. So let's go through a couple examples. In number 1, we see that the chords are congruent. And I know that they're congruent because of these individual tick marks. 2 on each tells me that these 2 chords are the same. So if the chords are the same, then the chords are the same distance away from the center. This value of 5 should be indicating this piece right here. So if the chords are the same, then they're the same distance from the center, so my value for x should be 5. In number 2, I do not indicate that the chords don't know that they're congruent, but instead I know that they're the same distance from the center. So because of the same distance from the center, I'm able to say that the chords themselves are also the same. This piece is 8, which means this piece is also 8, which means the whole chord is 16, so my value is 16. Number 5 is showing a diameter, or part of a diameter. If I were to extend it all the way, it would truly look like a diameter. I'm showing that that's perpendicular to a chord. So that goes to rule number 3. If a diameter is perpendicular to a chord, then it bisects the chord. So what I know is going to happen next is that these 2 pieces are going to be congruent. If these 2 pieces are congruent, then I see something forming here. This is a right triangle. I'm going to be able to solve for this piece right here. We'll call that y. I can set up the Pythagorean theorem. Y squared plus 6 squared equals 9 squared. So y squared plus 36 equals 81. So y squared equals 45. So y equals the square root of 45. And we can simplify the square root of 45. That's simplified to 3 times the square root of 5. Well, I know that that's just this portion here, just one part of the chord. I want the entire thing. So x is going to be twice the value that we found for y. So x is 2 times 3 square root of 5, which can be rewritten as 6 square root of 5, or if we plug this into our calculator to get our decimal answer, rounded to the nearest tenth, we have 13.4. So either of these two answers would be acceptable. Looking at number 8, a little hint. I have a diameter perpendicular to a chord, so again I know that the chord is bisected. If I were to draw this dotted line here, that is my radius. Just like x is my radius. So I could solve for this value and that would be the same thing. That's a little hint for you guys.